Welcome to Symbiotic Corporation's webinar, LactoSpore Probiotic of Choice. My name is Haim Prasad, Senior Vice President of Sales and Marketing for Symbiotic Corporation in North America. It is my pleasure to introduce Dr. Reza Kamarai, Vice President of Science and Technology for Symbiotic Corporation. Dr. Reza Kamarai received his PhD in Food Science and Technology from Massachusetts Institute of Technology, MIT, in 1982. He's worked at companies such as Angio Medical Corporation, where he was the Vice President of Bioprocessing Operations. He was also Cleantech Nutrition USA, which is a joint venture between Nestle and Baxter. He was the leader of the R&D department. He was also Director of Nutritional and Medical Food Ingredients at National Starch. He was the President of Princeton Nutrition, and he was a director in the nutrition department of Oceanic Institute. He was also the senior manager of nutritional juices, products, and ingredient sciences at Coca-Cola North America. Dr. Kamarai is currently Vice President of Science and Technology at Symbiotic Corporation, and he's also the Chief Scientific Advisor at SamiDirect. He's the inventor or co-inventor of more than 20 patents and author of numerous peer-reviewed papers. Today, Dr. Kamarai will talk about why LactoSpore is the probiotic of choice, including the novel probiotic, prebiotic, bilayered delivery technology.
Thank you, Haim. I'm happy to talk today about the LactoSpore probiotic of choice, one of the favorite ingredients at Sabinsa, especially in this 25th year's anniversary of establishment of Sabinsa Corporation. As the next slide shows, probiotics are live microorganisms which, when administered in adequate amounts, confer a health benefit on the host. In this context, the next slide shows and talks about LactoSpore. We can ask what's LactoSpore. Taxonomic nomenclature of LactoSpore is Bacillus coagulans. Bacillus coagulans was originally known in the literature as Lactobacillus aspergillus. These two terms are still used in literature interchangeably. LactoSpore, or Bacillus coagulans, is a non-pathogenic, non-toxicogenic microorganism. The next slide talks about the characteristic features of Bacillus coagulans. It is a rod-shaped, gram-positive, endosperm-forming bacteria. It's a facultative anaerobe and grows optimally at 37 degrees C and pH in the range of 5.5 to 6.2, slightly acidic. And it requires nutritionally complex environment in which they derive their energy via fermentation of carbohydrates. In fact, they convert carbohydrates to lactic acid. And they are more acid tolerant than pathogenic and spoiled microorganisms. As far as probiotic features of Bacillus coagulans is concerned, the next slide shows that when Bacillus coagulans or LactoSpore is ingested, it can withstand the acidic environment of the stomach. Within the GI tract, in the gut, spores germinate and proliferate, and after germination, then the probiotic is metabolically active as part of the facultative anaerobes in the intestine. It produces lactic acid as the primary product of fermentation. I have to say that the Bacillus coagulans is a temporary resident of GI tract. If we discontinue its administration, it's slowly excreted from the body, usually within 7 days or so. Next slide shows how this Bacillus coagulans survives and flourishes in the gut, in the intestine. It's through the mechanism, essentially, of the competitive exclusion. By that, I mean that there is first a competition for limited nutrients by all bacteria. And the point is that the acidic environment created by production of lactic acid now prevents the growth of pathogenic microbes and then allows the growth of Bacillus coagulans, which ultimately dominate the microflora of the gut. In addition, Bacillus coagulans also produces some bacteriocins. These are antimicrobial or proteinaceous compounds that may be inhibitory toward both gram-positive and gram-negative bacteria. Suggested doses of Bacillus coagulans is usually between 100 to 200 million spores 3 times daily. The next slide shows that the reasons that why we can use Lactobacillus, and we can choose, in fact, Lactobacillus as a probiotic of choice. Next slide shows reason number 1 for choosing LactoSpore as probiotic of choice, and that is because of the history of use. Dietary ingestion of lactic acid producing bacteria in general has a substantial history of use, and the safety record is excellent. For example, lactic acid bacteria are used in starter cultures for fermentation of foods. For instance, in the case of yogurt, that by acidification of the system, we get coagulation of proteins of milk and conversion to yogurt. And other products like kefir, sauerkraut, sausage, sourdough bread, the Nigerian product ogba, Korean kimchi, and so on. All these use lactic acid bacteria. Also, production of enzyme used for food production, insoluble glucose isomerase enzyme, as well as application dietary supplements, either alone or with vitamins, minerals, and prebiotics, etc. All these show a safe history of use of LactoSpore. Next slide shows where the production site of LactoSpore is in Samilabs, our sister company in India. This is the biotechnology building production site. Next slide shows inside that Sabinsa biotechnology facility. This is an FDA-inspected facility. Next slide shows that each batch of LactoSpore is checked through microscopy for phosphorylation and the purity of the batch. Next slide shows the finished product area, and the finished products are standardized in 2 different concentrations of these spores, either 15 billion spores per gram of final product or 6 billion spores per gram of final product. Next slide shows reason number 2 for choosing LactoSpore, and that is because of its stability. Because of the spore-forming nature of LactoSpore, it is resistant to most chemical and physical conditions, for instance, acid and heat, and survives manufacturing, shipping, and storage with no loss or almost no loss of viable count, as we will see. And it does not require refrigeration condition. It's room temperature stable. The next slide shows that if we heat LactoSpore under different conditions, for example, if trial number 1, if we heat it to 90 degrees C in hot air oven for 30 to 150 seconds, or trial number 2, same 90 degrees C this time in water bath for 30 to 180 seconds, and trial number 3 for 140 degrees C between 30 to 120 degrees C, you see the result in those boxes. You see that in all cases, total viable spore count in billions of spores per gram, how much initially it has been, and the survival rate of these from 100% upon excessive amount of heat goes in the first box up to 92.8%. The second box, the blue one, from 100% to 82.10%, and the last box from 100% to 75.98%. You see the condition is very harsh, 140 degrees C, yet more than 75% of these spores survive. Very resilient spore. Next slide shows the reason number 3 why we can choose LactoSpore as a probiotic of choice. And it's because of documented clinical effectiveness. Let's consider a few of these clinical studies. Next slide shows clinical study number 1, gastrointestinal health. This was the early work in Japan on 567 subjects. Let's take a look at the box inside. The conditions, for example, diarrhea due to acute and chronic gastroenteritis, 93.7% improvement in each cases, which corresponds to 118 patients over 126 patients. The other condition, maldigestion accompanied with diarrhea, 85.9% improvement. Infantile diarrhea, 87.9%. Constipation, 65.4%. All good and encouraging results. Let's take a look at the clinical study number 2 in the next slide. This is the infant gastrointestinal health in India, 112 newborn infants. Let's focus on the last 3 rows. Number of episodes in this infant of the rotavirus diarrhea. If they receive Lactobacillus aspergillosis, it's 3.4, but if they do not receive placebo, it's 8.6. Duration of each of these episodes, number of days, the treatment side is 3.6 days, while placebo 6.8. And the days ill for these newborn infants per year, 12 months, if they receive this probiotic is 13, and if they do not receive, 35. Next slide shows clinical study number 3, the serum lipid profile. When the subjects, in this case 17 patients, receive 360 million spores per day. And you see that in the box. It shows that the total over the HDL cholesterol ratio decreases by 24%. LDL, or so-called bad cholesterol, over good cholesterol, HDL ratio also decreased by 33%. Next slide, clinical study number 4, infant gastrointestinal health. This is again in India, has been done on 60 diarrhea patients, and you see that 49 of them cases cured, and for constipation, 3 of them all 100% cured. Next slide, it's a acute and chronic diarrhea in China. It's a randomized double-blind study. This is a comparison of Bacillus coagulans with Bifidobacterium longeum. And if you look at the result in the box, you see that for acute diarrhea and chronic diarrhea, both best effectiveness and total effectiveness, the rows of showing the result for Bacillus coagulans, all of them have better numbers than Bifidobacterium longeum, the lower row. So hopefully these depict the clinical effectiveness of LactoSpore, and as one of the advantages that this could be the probiotic of choice. Next slide shows that if we want to wrap up the potential application for LactoSpore, we have 2 major class of application. One of them in the GI tract application. The fundamental role here is normalizing the intestinal flora and immune enhancement. For example, dysbiosis, when there is an imbalance of bacterial growth in the intestine, that can be corrected. Infectious bacterial and viral diarrhea, and rotavirus, Shigella, Salmonella, enterotoxin, E. coli, Vibrio, HIV, all these can be affected by this probiotic. Antibiotic associated for enteral feeding, traveler's diarrhea, again another potential for LactoSpore. Constipation, digestive discomfort, lactose intolerance, IBS, irritable bowel syndrome, and those versions of inflammatory bowel disease, Crohn's disease, and ulcerative colitis. All of these are potential application of LactoSpore in GI tract. The next slide shows potential application for non-GI tract in urinary tract infection, hyperlipidemia, hypercholesterolemia, hypertension, high blood pressure, and respiratory tract infections. These are potential application of clinical application for LactoSpore. The next slide shows reason number 4 for choosing LactoSpore, and that is because of its GRAS status. GRAS, generally recognized as safe. And you see that this LactoSpore was self-affirmed in December 2008. 250 million colony-forming unit spores per person per day is safe, and you see number of food application versatile, too many to read at this stage. But this is another example, another reason that LactoSpore could be the probiotic of choice. And the next slide shows, for example, a application of LactoSpore in bread. Next slide shows application of LactoSpore in self-serve frozen yogurt. Next slide shows reason number 5 for choosing LactoSpore as probiotic of choice, and that is because of availability of matching prebiotic phenomenon. Let me first say what prebiotic is. A selectively fermented ingredient that allows specific changes both in the composition and or activity in the gastrointestinal microflora that confers benefits upon host well-being and health. If that is the definition of prebiotic, next slide shows phenomenon as a prebiotic, how that is produced. If you get the fenugreek seeds powder and extract fiber from that, you have phenofibers, or these are dietary fibers, components of fenugreek seeds, and then soluble fiber fraction of that is called phenomenon. Chemically speaking, phenomenon contains 35% to 45% galactomannan. Next slide shows talking fact in general about the soluble fiber advantage of that. We know the benefit of soluble dietary fiber in supporting digestive health, cardiovascular health, and wellness. All are in the literature, vastly studied. Also supports, we know that the soluble dietary fiber supports normal blood sugar and cholesterol level and a healthy body weight. But here, focus is on the prebiotic aspect of that, in addition to those benefits. Next slide shows that when we put those probiotic and prebiotic, we end up with a combination named symbiotic. By definition, symbiotic is a mixture of probiotics and prebiotics that beneficially affects the host by improving the survival and implementation, selectively stimulating the growth, or activating the metabolism of probiotic in the GI tract. Having said that, let's see when we put these two LactoSpore as probiotic and phenomenon as prebiotic, we end up with a product named LactoWise. And having that again in mind, let me pause and introduce a recent technology by Symbiotic Corporation named Integrated Nutritional Composites, INC Inc. This is bilayer delivery technology. This is shown in the slide with the picture. Now the next slide shows why they're using that. First of all, that is an innovation brought from the pharmaceutical industry to dietary supplement industry. The benefit or the value it offers is in its flexibility and formulation. When, for example, when ingredients are physically or chemically incompatible, you want to separate layers, or when ingredients should be manufactured at different processing loads, or when release of a layer should be programmed, for example, sustained release versus the regular release. or when apparent separation of layers is preferred, either for consumer education or for visual appeal. The next slide shows that this INC, ink, bilayer delivery technology has been successfully applied to LactoSpore phenomenon components of this system. And in fact, this bilayer of LactoSpore phenomenon is now ready for marketing, in case you're interested. But in addition to that, we can in fact mix and match probiotics and prebiotics. For example, you can take LactoSpore with various prebiotics, or you can take phenomenon with various probiotics, or you can have your specific probiotics and prebiotics and still have this bilayer deliver both of them in a nice fashion. The next slide simply shows this LactoSpore and phenomenon in the original color, which is the white and slightly brownish. And then if you want to, you can add a food color to a system to make it more pronounced in case interested. But again, you see that it can come in different shapes like tablets or round tablet or round pill or different colors. So it gives a lot of flexibility of probiotics, prebiotics, different shape, different form. Next slide shows where those bilayer probiotics and prebiotics are produced. This is the Sabinsa manufacturing. It's a world-class manufacturing site. It's in a beautiful place in Utah, Payson, Utah. It's a turnkey operation. The entire formula can be handled here, and they have steps and processes for blending, granulation, premixes, capsules, tablets, and stick packs. So in brief, if you want to conclude why LactoSpore may be or can be chosen as the probiotic of choice, these are the reasons that we very cover them in a very short fashion. History of use, stability of spores, documented clinical effectiveness, self-confirmed grafts, matching prebiotic phenomenon, ink, prebiotic bilayer delivery technology, and manufacturing support services. And the next slide shows that if you are interested in further information, you can visit these websites either for frequently asked questions on LactoSpore, or there is a white paper on LactoSpore probiotic of choice. Thank you.
Thank you, Dr. Reza. We will now move to the question and answer session.
So we have some questions, and the first question is, do you have stability data higher than 90 degrees Celsius?
Yes. In fact, slide number 14 shows that the LactoSpore has been subjected to temperature of 140 degrees Celsius for up to 2 minutes. Interestingly, more than 75% of spores tolerated this high temperature for 2 minutes. This means the LactoSpore is really a heat-resistant probiotic.
Thank you, Reza. The next question is, does your company work closely with us to develop a functional food containing LactoSpore?
The answer is yes. Our team of experts will work with your company step by step to ensure that your functional food containing LactoSpore is developed successfully.
Thank you, Dr. Reza. The next question is, your bilayer delivery technology seems interesting. If we want to run a pilot clinical trial on a bilayer tablet, can your company design and implement such a clinical trial based on good clinical practice, GCP?
Thank you, and I also think bilayer delivery technology is an interesting technology. Symbiotic Corporation has a wholly owned subsidiary named CleanWorld, whose exclusive activity is designing and implementing clinical trials. Such clinical trials are done based on good clinical practice and at a reasonable cost.
Thank you, Dr. Etter. We have another question. This is from Aldert Hoogland, and he says, we have encountered reluctance among manufacturers of probiotic finished products to work with spore-forming probiotics. Since Bacillus coagulans is such a resistant strain, it is also hard to remove in the cleaning process. What kind of solutions does Symbiotic offer for this problem?
First of all, I have to say this is a grass generally recognized as safe bacillus. It's not a harmful bacillus. It's not a pathogenic. So this is where we start with. And there are some standardized clinical procedure using the hydrogen peroxide vapors after cleaning the whole surfaces, working with these probiotics or any type of microorganisms, that through vaporization of hydrogen peroxide, you can sanitize the environment. And if interested, please contact us and we'll be happy to provide those procedures to you.
Thank you, Dr. Etter. We have a question from Alan Chung. He says, there has been a lot of talk about spore-forming probiotics of having the potential of being dangerous to humans because bacteria can mutate easily and spore-form probiotics are so resilient that if it becomes harmful, it will be very hard to kill off.
Yeah, this is a hypothetical question that what happens upon mutation. This question can be asked, in fact, for any type of microorganism and even the beneficial probiotic microorganisms. As I said, all the studies using this probiotic have been considered, reviewed by the toxicologist panel, and after that, in fact, the GRAS status, from the GRAS status has been obtained. So with our present knowledge, with all reasonable understanding, it's safe to use. As I said, this is only a hypothetical question.
The next question is from Celine Chesdeb, and she's asking, what is the influence of the various strains of Bacillus coagulans on the beneficial properties presented?
I only focused on our strains of Bacillus coagulans LactoSpore. If we try to use our scientific judgment, these strains are very close to each other, and usually they have very similar effects. If I want to use a layman term, it's just like, the slight different formulation of Coke and Pepsi, that they may be different, but you see that for all practical reasons, they do the same function. So I feel that Bacillus coagulans various strains should result in very, very, close outcome.
Thank you, Dr. Etter. The next question from John Deaton is it approved in Canada? And yes, it is under pending approval, and we should know very shortly. We have another question, again from Aldert Hoogland, who would like to receive the presentation as a PDF or a PowerPoint file, and he sent his email address. Absolutely. If you contact your Symbiotic representative, we can forward that to you. Also, it is downloadable from the website. The next question is, this is from Marie-Jo Clark. Is there stability on the bilayer tablet? And do you have clinical trials using a specific dosage form demonstrating efficacy?
I believe that the stability has been done separately on probiotic and prebiotic. Both of them stable at room temperature up to 2 years. I have to see if we have done a stability on these two compounds where they are in the bilayer format. But for all practical reasons, I believe when they have shown stability, each of the layers separately, and these are dry layers next to each other, there should not be any problem. My best forecast is it will be stable for 2 years, similar to the ingredients that form these bilayers.
Okay, thank you, Dr. Reza. So we have a question from Elizabeth. How does LactoSpore perform in patients using antibiotics?
Yeah, there are some studies on the effect of antibiotics on LactoSpore. If you're interested, please contact us, and we'll be happy to share that with you.
Okay, thank you, Dr. Reza. We have another question from Marita Clark. How does a spore meet the definition of live bacteria for use of the term probiotic?
Yeah, spores, of course, are live bacteria. Upon reaching the gut and having the nutrients and water and the right temperature, they germinate and they become a regular probiotic or microorganisms. If they were not live, they would not germinate.
Okay, I do believe that we're coming to the end of this. I think we can take one more question, and then the rest will be on our on the web. So we have another question from Elizabeth. Does LactoSpore germinate in fermented foods during cold storage?
We have to look at the optimal growth condition for LactoSpore. The farther we get from those conditions like presence of water or the lower water activity or temperature or nutrients, the more difficult for the spore to germinate and become active. So it's not a frankly clear-cut answer to that. We have to see each condition uniquely and say what are the probability of formation of the germination of the spores. And if you're interested to use that in a product, we'll be happy to work with you on that.
All right. Well, thank you very much, Dr. Reza, and thank you all for listening. We'd like to welcome you to continue looking at the website, and we will be answering the questions. It will be up for a number of months. So thank you very much, and thank you, Dr. Reza, for the presentation.
Thank you very much.
Thank you. Bye-bye.
Bye-bye.